Chitin is another starch that we're going to run into throughout biology. And it is only glucose molecules hooked together, but it is very structurally sound, and we find it in the exoskeleton of arthropods. So all of your insects from the class Insecta, also from the class Crustacea, this is going to be in the exoskeleton of your crabs, shrimp, oysters, those kinds of things, as well as your insects. So with insects, they don't have an endoskeleton that they have inside their body like we do. They have an exoskeleton, and that exoskeleton has to be shed, or what we call molt, in order for them to grow. But it's also found in the cell wall of fungus, and we can process chitin in our bodies. It's not like cellulose, but it is a structural, very tough structural polysaccharide. It's a starch, only glucose monomers, and we see this in the exoskeleton of insects as well as the cell wall of fungi. Now this picture just shows you the structure of chitin, the monomer, and it says chitin embedded in proteins forms the exoskeleton. Here you have got a insect, it looks like a cicada, that is molting. Chitin is also strong enough to where they can use it as surgical thread. They used to use catgut for this, but now chitin is a common choice when being sewn up, especially if you're sewing up internal organs, not so much skin, but when a surgeon is inside and he has to remove something and sew back parts together, chitin is generally the form in which is used. Okay, now this concludes our carbohydrates. Next, we are going to start our lipids. So I will stop right here, and this concludes our carbs.